ক্লাসে অ্যাটেন্ড করতে দিব না। ঠিক আছে? যদি তোমরা কেউ এন্ট্রি নিতে চায় তাকে এন্ট্রি দেওয়ার সুযোগ, এন্টার করতে সুযোগ দিতে হবে। আচ্ছা, আজকে আমাদের একদম লাস্ট চ্যাপ্টারে আমরা চলে গেছি। হ্যাঁ, অলিউল্লাহ আছেন তো না?
জি স্যার, অলিউল্লাহ আছে। ওর মনে কি বলে ল্যাপটপে হচ্ছে আপডেট দেওয়া লাগবে, তো আমারটা দিয়ে ক্লাস করতেছে।
কোথায় দেখি? এই ক্যামেরা অন করেন। সাইফুল হক হিমু। হিমু কোথায় গেল? হ্যাঁ, হিমু আপনি কি এখানে সাজেশনে দেখাচ্ছে কেন? ঠিক আছে, ওয়ালিউল্লাহ আছে। হ্যাঁ, তাহমিদুর রহমান, আপনি এখানে আইডি নাই এতে? এই হিমু, আপনি অ্যাড নাই
স্যার
এই
থাকা
ক্লাসে?
তো কথা স্যার, এটা দিয়ে তো স্যার সবসময় স্যার ক্লাস করছি।
আচ্ছা, আপনি কি ডিরেক্টলি আপনি ইয়াতে টিমসে ঢুকে আমাকে এই ইয়ে পান, জয়েনের অপশন পান টিমসে ঢুকে?
জি স্যার।
আমি হচ্ছে গেস করতেছি যে মনে রিকোয়েস্ট টু জয়েন, এই যে দেই তো, এই হিমুকে দিই রিকোয়েস্ট টু জয়েন।
আর স্যার আমি মোবাইল চেঞ্জ করছি তো স্যার, হয়তোবা স্যার এজন্য কোনো সমস্যা হয়েছে কিনা স্যার।
আপনার যে জয়েন হয়ে গেছে তো মনে হয়, না আবার চলে আসছে। আচ্ছা, যাই হোক, কারণ হচ্ছে টিমসে পরীক্ষা নিলে অথবা কোনো ডেটা কিন্তু আমি পাবো না আপনাদের, আপনারা যদি ওখান থেকে অ্যাক্সেস করতে না পারেন। এনিওয়ে, আমরা এখন আমাদের আমাদের কাজে চলে যাই এই নম্বরে। আচ্ছা, সিপিইউ শিডিউলিং লাস্ট চ্যাপ্টার। এখন আমরা আমরা একটু কি কি পড়াবো এখান থেকে সেই জিনিসগুলো একটু দেখি। সিপিইউ শিডিউলিংটা আচ্ছা, প্রসেস শিডিউলিং আপনারা বিভিন্ন জায়গা থেকে হেল্প পাবেন বিভিন্নভাবে। তো আমি কিছু ছোটখাটো নোট করেছি আপনাদের জন্য, ফলো করতে পারেন। আচ্ছা, সিপিইউ শিডিউলিংটা হচ্ছে আমাদের প্রসেস শিডিউলিং যেটাকে বলতে পারি, অথবা সিপিইউ শিডিউলিং যেটাই বলেন না, এটা সাধারণত কিসের উপর বেস করে হয় একটু বলি। যে মনে করেন যে আপনি দেখতে পাচ্ছেন না আমার নোটটা, তো দেখতে পাচ্ছেন?
জি
জি
স্যার,
স্যার।
জি স্যার, দেখতে পাচ্ছি।
আচ্ছা, এই প্রসেস শিডিউলিংটা কেন করা হয়? মনে করেন যে শিডিউলিংটা কেন করা হয়? এই যে বাসে যখন আপনারা ওঠেন, একজনের পর একজন ওঠেন, তাই না? এটা একটা শিডিউলিং, ঠিক
জি
আছে?
স্যার।
1 বাই 1 উঠে যাচ্ছে। তো এরকম আমাদের কম্পিউটার সিস্টেমের মধ্যে একটা যদি প্রসেসর হয়, কয়টা প্রসেসর? সিঙ্গেল প্রসেসর হয়। কিন্তু মাল্টিপল প্রসেস যদি multiple process need to execute using one processor. What happened in this time? In this time is very necessary. If all the cooperative process want to accessed by processes, ঠিক আছে? যদি মাল্টিপল প্রসেস যদি একটা প্রসেসর দিয়ে এক্সিকিউট হতে চায়, it is not possible. So in this case, the processes are needed to execute using different types of method. Okay, so এখানে আমরা দেখবো যে আসলে একটা প্রসেস এক্সিকিউশনের জন্য আজকে একটু বাংলায় নিয়ে একটা প্রসেস এক্সিকিউশনের জন্য খুবই ইম্পর্টেন্ট আমাদের অপারেটিং সিস্টেমের মধ্যে যা কিছু হচ্ছে whatever happening inside the operating system, inside an operating system, everything because of the process. If a process, multiple process want to share a resource all together, then it becomes hang. We can say this one is deadlock. মানে প্রসেসের জন্য ডেডলক, প্রসেস যদি ইফিশিয়েন্টলি এক্সিকিউশন হয়, তার মানে আমি বলি এই সফটওয়্যারটা ভালো। যদি প্রসেস ঠিক মতো এক্সিকিউট না হয়, খালি ঘুরে ইট মিনস দ্যাট দিস সফটওয়্যার ইজ নট গুড। ঠিক আছে, সো দ্যাট মিনস আমাদের যেরকম শরীরে, ফর এক্সাম্পল, ইফ উই হ্যাভ দি সেল, রাইট? আমাদের কোষ আছে, কলা আছে, তাই না? আমাদের শরীরের মধ্যে সেল মানে কোষ আছে। এই কোষটা যেরকম আমাদের শরীরের মধ্যে খুবই ইম্পর্টেন্ট এবং কোষের সমন্বয়ে গঠিত। একটা সমুদ্রের মধ্যে এক ফোঁটা পানি, ঠিক আছে, বিন্দু পরিমাণ পানি যেরকম একটা সমুদ্র গড়তে হেল্প করে, এরকম একটা সিস্টেম, অপারেটিং সিস্টেম করতে প্রসেসের ভূমিকা এরকম সেলের মতো। ঠিক আছে, আমাকে তো শুনতে পাচ্ছি না? আচ্ছা, এখন এই প্রসেসগুলো, মাল্টিপল প্রসেস যখন ওয়ান টু এক্সিকিউট ইন ওয়ান টাইম, it means that it needs it is very difficult, okay, impossible actually, to execute multiple processes in one processor. Okay, so in this case, we say this one is multi-programming. Okay, in this case we need the process scheduling. You can see the unit processor scheduling. Okay, so here this not come from the what called stalling books, not silver church. Stalling এর বই থেকে এই নোটটা কোর্স করেছি আমি। আচ্ছা, three types of scheduling. One is LTS, one is MTS, another one is STS. LTS means long-term scheduling, MTS means mid-term scheduling, and STS means short-term scheduling. Okay, then I will show you how this long-term scheduling, mid-term scheduling, and short-term scheduling when happening, these schedulings. Okay, scheduling, they have decision mode. One is non-preemptive, another one is preemptive. Okay, one is preemptive, another one is non-preemptive. Preemptive means, non-preemptive means once a process start to execute, it complete its execution. You can write down, once the process start to execute, it will complete its process execution. It means that there is no interruption within the execution duration. That means within the execution time, there are no interruption. Okay, and preemptive means there is interruption. Okay, during process execution there is interruption. This is a preemptive one. Okay, short-term scheduling, so we have three types of scheduling, right? LTS, MTS, and STS. STS means short-term scheduling. This is very important. So short-term scheduling, we can divide it into non-preemptive and preemptive part. In the non-preemptive part, we can see FCFS, SGF, HRRN. Okay, and for the preemptive part, we can see SGF, shortage of first, priority, and round robin. Clear?
স্যার এসজেএফ যে দুই জায়গাতেই আছে।
Okay, this is mode based, non-preemptive, and this is preemptive. Priority also we can do non-preemptive. Some books you can find, like Silverchair's book, they have executed this priority scheduling inside the non-preemptive mode. Okay,
Sir,
so
what is HRRN?
HRN, highest response ratio. Next, I will show you. I think the other teachers are not teaching you this one, highest response ratio. So, but I will teach you in future. Maybe you may need this. Okay, highest response ratio. So now I will go through one by one, but using one example. Using one example. Like here is non-preemptive. Okay, before going to the uh, demonstration, I need to show you some terminologies. Okay, I would like to show you some terminologies. You can see here. There is some term. It's called round robin turnaround time (TAT). We can call it TAT. Some places I can call this one as a TOT. Then process completion time, you can call it CT. Okay, service time, you can call it ST. We can call this service time in different ways. For example, service time, execution time, running time, RT, burst time, BT. These four types you can see in the question. Maybe these four types, anyone, whatever you get, all are all the meanings are execution time. That means during a process executing. And the other one is waiting time. Okay, we can call it WT. So here we can see the process shielding. Sometimes there is some question. There are some question why the process scheduling is necessary. Okay, why the process scheduling are necessary. So we can say from here the multi-programming, multiple processes execute concurrently. Okay, multiple processes execute concurrently inside the main memory. Okay, so in this situation, the key term, the key point of the process of multiprogramming is scheduling, because the processes will execute concurrently. We will see after that. Okay, we will see after that when during our demonstration we can see that. Okay, the third one is scheduling affects the performance of the system because it determines which process will rest and which process will progress. Progress means execute. Okay, the aim of process scheduling is to assessing processes to be executed by the processor, which meet the system objectives. Okay, that means this divided the types of, just now I said that there are few types of process short-term scheduling, right? Like FCFS, HF, priority, HRN, correct? So why this type of process scheduling came to the market? Because of few objectives. Some we can say that some process scheduling method or algorithm like FCFS, it has different. Initially, FCFS was there. Then come to the then come the another algorithms, for example, SJF, because FCFS have some problem. So to overcome that problem, SJF is come invented. Then SJF also have some problem. Then there is round robin invented. So like this way, for different purpose, different types of algorithm invented by the scientist. Sometimes because of the throughput, some algorithm its throughput is good. So we approve that the what call the community approve that algorithm. So like this way, for different purpose, different types of algorithm invented through the scientists. Okay, the next one is if the idle time is little of a processor, okay, then it's called, okay, it's called the high efficiency. High indicates, it's indicate high efficiency. That means idle time is little, that means always working. If a processor always working, okay, always working, it means its efficiency is high. Okay, then, and what about the throughput? Throughput means wherever you use the throughput, throughput indicates that, for example, in a road, the maximum what called the speed limit. What is the maximum speed limit in a road? For example, in our highway express is 880, 70 to 80. 70 to 80 kilometers per hour. It means its throughput is 70 to 80 kilometers. Clear? So throughput, now we can understand. মানে throughputটা বলতে বোঝাচ্ছে যে আমাদের ম্যাক্সিমাম লেভেল, যেমন আমার ল্যাপটপে থ্রুপুট আছে, আমার ল্যাপটপটা কোথায় গেল, যে আমাদের যে ইয়েটা আছে হার্টস, যেটাকে বলা হয় ম্যাক্সিমাম কত হার্টস পর্যন্ত তারা প্রসেসরের স্পিডটা বাড়াতে পারবে, ঠিক আছে, ম্যাক্সিমাম স্পিডটা দেওয়া আছে, ইট মিনস ইটস থ্রুপুট, এই ম্যাক্সিমাম স্পিডটাই থ্রুপুট। এরপরে জাস্ট we have seen that long term scheduling, mid term scheduling, short term scheduling. So long term scheduling actually সেটা কোথায় কাজ করে, where it works. Before going to discuss this one, we need to see, I don't know, I have a note here. Don't have here, but you can see in the book 5-step process model. I can show you 5-step process model. It to show you 21. Okay, I would like to show you one 5-step process model. Five-step process model. Okay, then we can see here. Have process scheduling, I management before I management. I think 11, chapter 11 is process scheduling. The scheduling, sorry. And 9. Sorry for that. Just taking time. I forgot to open this book. It takes time. Yes, that's correct. Okay, here you can see that long-term scheduling, mid-term scheduling,
তার
and
স্ক্রিন শেয়ার অফ হয়ে গেছে।
okay. There you go. We can see here. Can you see? Long-term scheduling, mid-term scheduling, short-term scheduling. This is the stalling books. Very nice written, nicely written. And scheduling algorithms are here. Okay. I just want to show the 5-state process model. 5-state process model. This is the so I'll come here for the scheduling algorithm. Here you can see that long-term scheduling use new to ready. Okay, long-term scheduling. And medium-term scheduling only ready or suspend. This is step 2, ready. That means they blocked or suspend or blocked to blocked. Here also medium-term scheduling using. Only short-term scheduling is used ready to running in this place. Ready to running in this place. Okay. Short-term scheduling are using. Clear? So this is called short-term scheduling. So short-term scheduling, I would like to show you that we have few state diagram. Okay, one is I'm just seeing here, so I'm showing you 5-state diagram. What is that? No. All the state diagram are here. What is that? Scheduling algorithm. Okay, I think the later one is states diagram given here. Oh, sorry, this one not here. This state diagram we learned in the first before meet. Can you remember? Five-state process diagram, 2-state process diagram. So here you can see only where we can use here. Just we can see that where we can use the scheduling algorithms. Okay, long-term scheduling algorithm, mid-term scheduling algorithm, and short-term scheduling algorithm. So last time I gave one question about what algorithm are you using in running between running and exit. So between running and exit, there will be no algorithm because after complete the running, then it goes to the all the variable are released, okay, and complete its execution. So because of that running and between running and exit, there will be no, but there will be no algorithm. Okay, here one thing I just would like to show you. Just for your information, so some terminologies are here. You can learn from here the terminologies. Okay. Okay. Here are a few tables. You can find the tables here. Okay, just I would like to show you in my note that type of scheduling, long-term scheduling, how when it happens is performed when a new process is created. That means যখন একটা process create হয় তখন সেখানে কি হয়? What happened?
LTS use হয়।
LTS. Okay, then midterm scheduling, I would like to show you midterm scheduling. What happening is a part of the swapping function and determines when a program brought partially or fully in the main memory. Okay, so in this case, that means partially full completed. is not fully completed. Okay, if any process need to execute. Sometimes I mean, before I discuss about that. For example, we have browser. Long term I'm using, suddenly my memory is very low. Okay, suddenly our memory is very low. During that time, we need to share the main memory, correct? In this case, the browser open like few tabs will be open and few not opening, right? It means that the browser is not getting proper information to execute, to execute in front of us. So in this case, some part come, some part not come, some part come, some part not come, like this way. Then we say that we say that very slow, computer is very slow. Actually, what happened? All the information, that means the process, if you can remember for the 5-state or 6-state, 7-state diagram, all the processes, they stay in the block state, right? From the block state, they go to the running state. Clear? So in this case, all of this type of processes from the ready state. So we can say that this process is in under midterm scheduling. The short-term scheduling means I just say that determines which ready process will be executed next by the processor. That means which next processes, what new processes, that means what are the ready process is there, need to find out, and that ready process which one will execute first. Okay, ফর এক্সাম্পল আমরা যদি বলি যে আমরা একটা বাসের গেটের কাছে দাঁড়ায় আছি 4-5 জন, এখন কে আগে যাবে এইটা নির্ধারণ করবে। বাস কিন্তু আমরাও রেডি আছি, বাসও রেডি, এখন কে ঢুকবে আগে, হ্যাঁ, এটা হচ্ছে নির্ধারণ করে হচ্ছে শর্ট টার্ম শিডিউলিং অ্যালগরিদম। ক্লিয়ার? আচ্ছা, এখন আমরা কিছু টার্মিনোলজি দেখবো। এই যে শিডিউলিং ডিসিশন যেটা আছে, নন প্রিএমপ্টিভ এবং প্রিএমপ্টিভ বলছিলাম। নন প্রিএমপ্টিভ হচ্ছে প্রসেস এক্সিকিউশন উইদাউট এনি ইন্টারাপশন, preemptive process execution with interruption. Some definition we can see TAT. You can see the TAT. TAT means turnaround time. Time interval from the arrival time. Okay. TAT. TAT. Arrival time until completion time. Okay. So you will be familiar slow one by one, inshallah. Okay. The TAT TAT is equal to WT means waiting time plus ST means service time. Okay. Sometimes we can see BT, burst time. So TAT we can define in another way, CT minus AT. That means completion time minus arrival time, AT. Yeah? So here we can see the definitions, all the abbreviations. Okay, then we can see the ST. This is service time. Service time means how long a process executing. That execution time means ST, service time. Process completion means why the process fully completed. After that, no further continuation. Okay. Process completion time, just now say. And waiting time means, for example, if a process supposed to execute at for example after 5 minutes, but after 5 minutes I'm just waiting, but the process is not arrived. This is waiting time. How long? The waiting time. Okay. Okay, now we go to the first problem is FCFS. I will try to show you. I'm trying to show you the same problem for different types of algorithms. Okay. Now I'd like to show you the first come first service. So I have the processes is given, will be in the question, you can find like that. Process A, B, C, D, E. Okay, and the arrival time is the process will arrive at 0, but service time is 3. That means it will execute 3 millisecond ms. You can see in front on the top. Okay, B is supposed to come at 2 p.m. Sorry, 2 milliseconds. Supposed to come at after execution start. B arrive at 2. Okay, B arrive at 2. Then from because 6 already this 6 already we have, right? How many times? Like 6 milliseconds this process can execute, but it has arrive time is 2 means here is 2, right? Arrival time is 2. That means after starting from 0, during 2 milliseconds, this B arrive. Okay, the B arrive. Like this way, C, its execution time is 4, but during 4, during the 4, what happened? The C came to the timeline. Same way, D, during the 6 millisecond, D arrive. During the 8 millisecond, E arrive. So, like this way, we can see this table is produced and given to the to us to solve the problem using FCFS. First come, first serve. Okay, first come, first serve. Which process will execute first? Clear? So if we have to do this one, we have to write the Gantt chart. The main part is the Gantt chart. Once the Gantt chart finished, then others are easy. Okay, I'm showing you only one, how to solve only one problem. Then next problem, I will not discuss the further. I will discuss until the word. Okay. So Gantt chart we can see A, B, C, D. Okay. This before doing that, I think how we made this Gantt chart, because this is non-preemptive, right? FCPS is non-preemptive. That means A start from 0. We will see which one starting from first. If we do the serial A first, because A start from 0, then B is starting from 2, C is starting from 3, 4 is 4, sorry, C is starting from 4, D starting from 6, and E starting from 8. That means we have the serial A, B, C, D, E. Okay, we have the serial. So A, we can see that arrival time is 0. That means it's arrived on time. Whoever given the time need to follow that. So because non-preemptive, that means A needs 3. You can see A needs 3 instance 3 millisecond time to execute. Then it means 1, 2, 3. A got 3 millisecond to execute. Clear? Okay. B it start from 2. That means 2. But from the 2, B supposed to give, but cannot because A is running. So wherever if complete, B need to give. B need to give chance. So it cannot touch the B because B already occupied by A. So it will take, after the A, it will take 6 millisecond. That means 1, 2, 3, 4, 5, 6 millisecond. Okay. Then we have C, right? C. Once B finished, then we execute the C. That
Sir,
means
here
B,
C arrives at 4 millisecond, but
C arrive at 4
9 millisecond. That
because B,
means it is waiting, right?
yes, correct. So it arrive at 4, but start at 9. That means 1, 2, 3, 4, 5. 5 millisecond. C will wait. Okay. So likewise, after C, there is D. D start after C. But we can see that D already started at 6, but during C execution, it was 13. That means after C execution, it becomes 13 milliseconds, correct? That means how can we get the waiting time of D? Of course, the 13 minus 6. That's 9, is it?
So we can subtract the executing time minus
Yes, that
arrival
means
time.
now D need to wait. D need to wait 1, 2, 3, 4, 5, 6, 7. 7 millisecond need to wait. D arrive at 6, but we give him chance 13. Sometimes what happen? অনেক সময় আমি বলি না যে তোমার জন্য অপেক্ষা করছি 10 মিনিট ধরে কিন্তু তুমি আসো নাই। I am waiting for you for 5 minutes. You have not come. It means that D already arrived at 6 millisecond, but because of the non-preemptive need to give the what call the this they need
So
to follow
no
the sequence. Huh?
So no intervention.
No intervention, no interrupt here. So like this way, D, E, clear? Okay, the next thing is you can see okay. So I just want to show you FCFS. This one is FCFS, okay? This one is FCFS. So in this case, we can see here, this is the table we need to write down. So we need to write CT, TAT, and WT. Okay. CT means completion time because our Gantt chart done, right? Until 20. Our Gantt chart is done until here. So we need to find out CT means completion time. So what is the completion time of A? So our A completed 3 milliseconds, right? See,
Yes, sir.
3 milliseconds. A. What is the B completed?
9 millisecond.
9 milliseconds. See, 9. This is the 9. What is the D completed?
So T at 18.
8. No, C is 13, right? C is in
C is
13.
13, yes.
D is 18 and E is
20.
20. See? So it means that we need to draw this table, okay, for our calculation. Okay. Turnaround time, we have seen that turnaround time is definition. Turnaround time,
Sir, from arrival time to the completion time.
is see. Turnaround time we can say WT plus ST or CT minus AT. CT minus completion time minus arrival time. See, completion time minus arrival time. Completion time and arrival time. Completion time minus arrival time. CT means completion time minus arrival time. Completion time is 3, arrival time is 0. That means 3. And B completion time is in 6, arrival time is 2. So
Sir, B completion time to 9.
sorry. Completion time is 9, arrival time is 2. That means 9 minus 2 is equal to 7. বুঝে আসছে? টার্ন
sir.
টাইম হচ্ছে সিটি মাইনাস এটি। এটা বিয়োগ দিবেন ইন্ডিভিজুয়ালি বের হয়ে যাবে আসবে। আচ্ছা, এটা গেল। এখন কথা হচ্ছে যে আপনাদের যে কাজটা দিব আমি আর 11টা বেজে গেছে। আমি যে কাজটা দেব সেটা হচ্ছে প্র্যাকটিস। প্র্যাকটিস মানে কি, যে আমাদের কনভয় ইফেক্ট। এই যে দেখেন, মনে করেন যে আমরা অনেক সময় হয় না যে কনভয় করে মোটরসাইকেল দিয়ে রাস্তার মধ্যে, দেখছেন কেউ কনভয় করা দেখছেন রাস্তায়? কনভয় করে, যে কনভয় করে, যে মনে হচ্ছে অনেক ছেলেপেলেরা মোটরসাইকেল নিয়ে অথবা গাড়ি নিয়ে
জি স্যার।
রাস্তা দিয়ে একসাথে যায়। যার ফলে কি হয়, পিছনে ছোট ছোট গাড়ি, কার, বাস, এগুলো কি হয়ে যায়, জ্যাম পড়ে যায়। কারেক্ট? তার মানে তাদের কিন্তু গন্তব্যস্থলে পৌঁছতে দেরি হয়ে যাচ্ছে। তাহলে ওয়েটিং টাইম তাদের বেশি হয়ে যাবে না?
জি স্যার।
কোনো সিস্টেমে যদি ওয়েটিং টাইম বেশি হয়, ইট মিনস দ্যাট সিস্টেম ইজ নট গুড, তাই না? সেই জন্য এটাকে বলা হচ্ছে কনভলিউটেড। আমাদের অপারেটিং সিস্টেমের মধ্যেও দেখা যাচ্ছে কিছু কিছু বড় বড় প্রসেস এক্সিকিউশনের জন্য ছোট ছোট প্রসেস গুলো এক্সিকিউট হতে পারে না, মানে যাদের কম সময় লাগবে। ঠিক আছে? এই ধরনের প্রবলেমটাকে বলে কনভয় ইফেক্ট। কি বলে? কনভয় ইফেক্ট। এটা লিখে রাখেন, গুগলে সার্চ দিয়ে দেখে নেবেন। এক্সাম্পল অফ কনভয় ইফেক্ট ইন অপারেটিং সিস্টেম। এটা পড়াবো না, আপনারা নিজেরা করবেন। ইম্পর্টেন্ট কিন্তু খুবই, কনভয় ইফেক্ট। ঠিক আছে? তো এখানে দেখবেন যে তার মানে কি, এখানে 3, 6, 4, 5, 2, দেখেন 2 কিন্তু অনেক ছোট, তাই না? In this case, this is supposed to execute first, but why cannot? Because its arrival time is late. Understand? But we execute 3 because 3 we execute 3 first because it's started at 0, right? Okay, but it is supposed to start first because it service time is 2. Okay, to overcome this convoy effect, the scientists thought that how can we overcome this convoy effect? They found the SJF, shortest job first. Here we can see our average turnaround time is equal to 3/5. Sorry, 43/5. You can see the add. You can add 3, 7, 9, 12, 12 is 43, right? Waiting time is 0, 1, 5, 7, 10 is 23, correct? So average turnaround time is 43 divided by 5. This 5 processes there. Average waiting time is 23 divided by 5 is 4.6. This is the important, okay? From this, because we have FCFS, HJF, priority, round robin, many programming languages, okay? Programming, many methods. So in this case, which one the algorithm whose waiting time is less, it means that algorithm is better. So in question may come, in exam may come, for example, 3 algorithm is written, given 3 algorithm you need to do, and saying that which one is better from your analysis. Then we need to find the average waiting time. Whose waiting time is less, it means we can say that this algorithm, process scheduling algorithm, is better than others. Clear? So next class, I will ask you the example of convoy effect. Then I will ask you, the convoy effect, and the others algorithm. I will continue. Okay. Okay. I think for today you have class, right?
Yes, sir. We have another.
After
Yes, sir.
another class. I think for today is okay. Thank you.
স্যার অ্যাটেন্ডেন্সটা বলেছিলেন ক্লাস শেষে ঠিক করে দিবেন।